Okay, welcome back. This is one more example out of Chapter 7. This is into the chapter problem number 8. The first step in that problem is to draw a process flow diagram, and so you can see that on the screen here. And so here's each of our steps. So we got the clerk, and it takes 3 minutes for every patient, and so forth. You can see at this point there's a decision in which we've got a branch of 40% go through the PA, 60% to the medical doctor, and so forth. Come back together, go through the billing step. Okay, and the rate at which patients are arriving, and the demand rate is 10 patients per hour. Okay, well, after doing the diagram, the next stage is to look at what is the throughput rate at each step in our process. Now, what we're given here is a time of 3 minutes, and for a single server, we can think about the relationship between time and rate is if you know the time, the rate is the inverse of the time. Okay, so if it takes 3 minutes per patient as a time, the inverse of that is 1/3 patient per minute. So that would be the rate at which this clerk processes patients through that step. If you're going to convert this to patients per hour, and then we just think about 60 minutes in an hour, cancels out. That's what gets us to 20 patients per hour as the rate at this step. Okay, and so in a similar way we get the 10 patients per hour, 12 patients per hour. This top branch for the PA is 10 per hour, 4 per hour for the doctor, and then 12 per hour. And notice that this smallest rate, 4 for the doctor, would be the bottleneck rate for the process. So that would be the rate at which this process would operate. Now the next step in the problem is to look at the utilization for each step. If we go back and think about our utilization formula, that utilization is the demand rate divided by the service rate times the number of servers. In this case we're saying one server. So it's the demand over service, what we're being asked to do over what are we able to do. So for this first step, the demand is 10 per hour, and we can do 20 per hour, and so that gets us a 50% utilization. And then pretty similar here and here for getting that. Now up here, 40% of the 10 patients per hour go to this step. So really our demand up here is 4 patients per hour. Demand down here is 6 patients per hour. Okay, and so because of that, that's how we go from having a availability, a service rate of 10 per hour to give us a utilization of 40%. Okay, where over here we've got a demand of 6 per hour. We have a service rate of 4 per hour. So that would give us 6 divided by 4. That's why we have the 150% labor utilization at this step. And again, that would be our bottleneck rate. Down here we're asked to really back into, if you had 100% utilization, then how many doctors would we need? How many servers would we need? Okay, and so if you remember the formula, this 7.2 formula, we have our demand rate divided by the service rate times the number of servers. Okay, we're going to set that equal to utilization and make the utilization 1. The demand rate here would be 6. Our service rate is 4. So if we solve for the number of servers, then we would need to be at 100% utilization. That's where we get the 1.5, or if you round it up to the next whole number, 2. And then we see that if we did have, in fact, 2, that would be a 75% utilization. So that's the first parts, I believe parts A, B, and C of that problem. Thank you.